Hi, everyone. Welcome to our battery talk show series, where we'll be talking to different experts from all over the world regarding battery technology and how it could be relevant to a country like Nepal. And for this episode, we're talking to Mr. Arjun Bhattarai. Welcome, Arjun, sir.
Thank you, Anjalji, for the opportunity and pleasure to talk in this show.
Sure. And thank you so much. So, could you let us know a little bit about your journey and your background and what led you to start this startup in Singapore?
Sure. I studied in Nepal, so I completed my undergrad from campus, IOE. Then I've been to Germany for my master's degree. So there I also studied mechanical engineering with specialization in renewable energies. So I was mostly looking into batteries, renewable solar PV, wind turbines, and fuel cells and other technology. So one of my work during the masters was mostly on the fuel cell technology. So on the basically hydrogen fuel cell on the hydrogen car vehicular application. So I worked at Fraunhofer Institute for a couple of years, mostly on the fuel cell. So as a researcher. Then I decided to come back to Nepal. So basically, I wanted to start something there, which was mostly my undergrad work, which I saw during my one-year thesis that there's a big opportunity with biomass. So in Nepal, I started a company, Namuna Biomass Private Limited. So basically, we converted all the waste biomass, invasive weeds like Banmara and other invasive weeds, and convert to charcoal. So this is still working and ongoing company based in Chittagong. Then after 1.5 years, I came to Singapore for my PhD. So there was a German collaboration project where there was opportunity to work on fuel cell and also I mean having fuel cell background. So flow cell was quite similar, and I thought it's a good opportunity, and then come to Singapore. But I was working on vanadium redox flow battery, and I was working almost for 4-5 years on the pure research on the system level development and solved a couple of problems on this technology. And back in 2018, then we decided to commercialize technology. So we had a couple of IPs developed, patent developed from this research, and thought that will add value and we will be competitive in the market with flow batteries. Therefore, we started this VFlowTech in 2018. It's almost going to be 4 years now by May. So we are moving quite well. Basically, we have launched a couple of products like 30 kilowatt hour, 100 kilowatt hour, and half megawatt hour systems are being deployed in various parts of the world. And yeah, this is how my journey is so far. And I'm leading the company in terms of technology development, and I'm one of the co-founder. And together with my co-founder Abhishek, he also from Singapore only. So this is how the journey is so far.
That sounds great. I mean, you touched upon this briefly, but yeah, the vanadium flow battery concept sounds very novel to us, especially in Nepal. I mean, obviously, we used to the lead acid battery, lithium ion is a new concept. So could you tell us a little bit about vanadium flow? How is it different from the batteries, and why is it so exciting?
Yeah, basically, the most common so far in the industry, mostly in Southeast Asia or South Asia region, was lead acid battery for all this application. And lithium ions slowly start coming up, and you hear this name more often due to mainly the EV industry and portable application. So therefore, you are aware of lithium ion batteries. But there are certain applications where you are looking for large scale energy storage application, where this flow battery fits well. So basically, flow battery is not like, you can do an analogy with your car. So basically, you have your car engine, which is like a battery stack, and you have your oil tank, which is like your energy storage. So basically, the power and energy are decoupled or separated, or you can separate it design in flow batteries. That's the beauty of this technology. So having said this, basically, if you need more kilowatt or megawatt, you simply increase your car engine capacity. And if you want to discharge or power your loads for longer hours, basically you just increase your tank capacity. You feel more liquid, you run longer. So this is how the flow battery are different compared to lithium ion and lead acid, where you don't have this opportunity to separate the power and energy. In terms of pros and cons, I would put like this. In terms of like pros, they are uh, the lifetime is super long compared to what you have with lead acid battery or lithium ion batteries. So typically they can go 10 to 20,000 cycles. So usually for energy storage application, you are considering per day one cycle, one charge cycle and one discharge cycle of the batteries. So if you count this, they can easily be more than 25 years. And with proper care and maintenance, it can go like decades. So that's not a issue at all. Uh, the other application or other advantage of vanadium redox flow battery, the main vanadium chemistry, basically it's a vanadium mixed in sulfuric acid. So this never degrades. So you can get it lifetime, I mean infinite life. Even after the shelf life of the battery, you can get the vanadium back. And this is the reason why you don't have a capacity decay. Basically, whatever energy capacity in terms of kilowatt hour or megawatt hour you are getting today, you will also get the same in 25 years, which is not possible in lithium ion batteries or lead acid battery. And the major point here also is the safety as well, because battery is something people worry about the safety, and mostly it came from the fire safety issue in lithium ion batteries. In vanadium redox flow battery, it's basically majority is water only. So it's non-flammable chemistry, so there is no risk of fire. Apart from this, in the electrical topology also, lithium ion works at much higher voltage, and we are usually operating at lower voltage. So safety risks are lesser. So flow battery are more safer technology and longer life. You might be asking why not flow battery everywhere? So there are certain niche applications where you cannot use vanadium redox flow battery or other flow chemistry. One reason is that they are bulky, because it's a flow chemistry. So compared to solid state or semi-solid state chemistry or gas state, I mean, liquid comes in between. Therefore, your energy density is lesser than lithium-ion batteries. Therefore they are bulky and heavy. So not for the vehicular application like vanadium flow battery would be suitable, but for the stationary energy application, they are quite a good solution.
Yeah, thank you so much. I think that was a great explanation, especially the car analogy. Now, just in terms of applications, flow battery, just by virtue of it being liquid based, is as you said, more bulky and less suited to certain applications. But just for folks in Nepal, where do you see like flow batteries being more efficient?
I mean, there are variety of application area, and in context of Nepal, so one possible area is telco industry in terms of small batteries, because you have to bring your battery uphill, and also maintenance is a big issue. So having those kind of battery where you don't need a regular maintenance or replacement of the battery, definitely your cost on maintenance and replacement will go down. So this would be one possible area for Nepal. Microgrid is growing. I mean, any countries like urban or even villages, they are equally suited. So basically, microgrid means that rural electrification or remote electrification, where you have your energy generated from solar PV, from wind turbines, where you want to solar or wind are intermittent and they are not 24/7 available. So you can basically use this flow battery. As I said, your power and energy are decoupled. So you can just design like 10 kilowatt and 10-hour backup, or even 20-hour backup. So basically for those areas where your solar is available for 4 to 5 hours a day, you can charge the battery with solar PV and then discharge the battery over the night, power the village 24/7, reliable energy supply. So these are the one very useful application for Nepal and other part of the world. In terms of generation side, definitely like NEA and other authorities, like they can use it for peaking hour. Basically, flow battery is a hydro in a box. So basically, it's a containerized hydropower. So you can store the excess energy when the energy prices are low. You can charge the battery and then basically discharge during the peak hours. So frequency regulation, peak saving, all this kind of application, they are equally useful. Also, they have a very good application in residential market. So basically, there is a very good tariff that your solar, I mean, the price variation is there. So in the daytime, probably you wish to charge the battery because there is a generation, and in the night time or peak hour you can discharge the battery. So basically you can self-consume and become zero energy. So self generation and self-consumption, and excess energy can be sold to the authority. So residential market is also quite a good market for flow batteries.
Also in Nepal, besides residential clients, right? So certain business customers also have a time of day tariff, right? So meaning the tariff from 11 p.m. to 6 a.m. is significantly cheaper than your peak time tariff, which is 6 p.m. to 11 p.m. And then that obviously the reason being that the demand is quite high in the peak hours, right? So especially with this technology, so can these small businesses who have a time of day tariff also like reduce their overall cost of energy?
I mean, definitely there is a potential. A bit of a concern for market in Nepal is because your electricity prices are not that high as in countries like Singapore or Australia and other countries. But still, like if you are looking on the big, huge batteries where you have longer duration storage and coupled with solar PV and other renewable sources, there is still a market. But usually we need to look into the ROI, how many years we will get the return back. So it's a financial engineering. There are certain aspects in flow battery. Basically, your like capex can be reduced from different models. So there is definitely opportunity. But yeah, as I said, there is a bit of financial engineering you have to do. So as your size goes larger and the power to energy ratio becomes wider, meaning that if you want to discharge a battery for at least 4 hours or more, flow battery will be more economic for those applications.
Sounds good. Thank you so much for your explanation. So just like going back to use cases, especially in international markets, you mentioned Australia and the residential homes there, right? And they're taking advantage of the differential tariff to make batteries economically feasible for them.
Yeah.
What kind of other use cases exist, and especially in the markets where you're working at?
Those applications where we can completely take out or eliminate the use or minimize the use of diesel generator and have a renewable source, solar PV, wind, battery, and supply to your various load. There, the economy is best fits, and you can ensure the 24/7 reliable supply. There is also inquiry in terms of like at the generation side. For example, frequency regulation. I mean, there are certain, I mean, depends on the country as well. Like, I don't know how much it will be relevant for Nepal right now at this condition, but like in developed countries, like your power reliability, they are big concern, and also the you have a certain tariff or penalty if you are exceeding a certain limit. That is what you have granted for. So for those peak saving or peaking application, you can definitely use this battery to save this penalties and have the uh, power reliability. So these are also application. Apart from this, we have also inquiries from data center, because data center are something that 24/7 they have to be operating, and they don't afford any power cut. So flow battery can be suitable technology for those applications as well.
That very good examples. Thank you so much. Now, I think especially in the context of Nepal, like whenever I think of new technologies, the first thing that jumps to my mind is the capacity to install it and to maintain it, because these are like long-term infrastructure assets, right? So just in terms of long-term costs associated with these projects, I mean, like what's the cost like in terms of O&M of these batteries?
I mean, usually from our experience and what others are doing, I mean, you need certain kind of yearly or once in 2 year inspection of the system and do some maintenance. But for it depends, because it's for megawatt level system, definitely it's needed. A small system, we have made it modular so that there is a minimal modification needed. And also we train the local authority, because one interesting part in handling this battery is that the chemical is same concentration, but the sulfuric acid concentration is same as your lead acid battery. So every street or everywhere you can find there are people who is handling or doing the servicing of lead acid battery. So basically you can just get the local technician to do servicing of this battery, and we can train people locally.
I think just the fact that the local technicians can train it, I think will help a lot. But just like you also mentioned during that answer that acid is involved, and obviously a lot of concern around battery technology is with recycling of the batteries, right? And then obviously the environmental aspects of what would recycling of these batteries need, right? So could you give us just brief information on the impact of these batteries on the environment, and how do we dispose of these batteries when the life of the battery ends?
Yeah, certainly. The major concerns in batteries is the chemical waste. Okay, so the container and other are not a big concern because they can be reused and can be easily recycled. The beauty of flow battery, or especially in vanadium redox flow battery, that, as I said, your electrolyte or the chemical does not degrade at all. So even after the shelf life, you can just take the liquid as it is and use in another battery, or you can sell back to your mining companies. So after the shelf life of the battery, we can buy back the electrolyte. And this is also not only us, because one interesting part is that the concentration of vanadium in the electrolyte is quite huge, that a miner, when they get from their mining, the purity or the quantity amount of vanadium available in the mine is much lesser than what you get in the electrolyte. So the mining companies will be more than happy to take this back and get the electrolyte back. So the main use of vanadium today is the steel industries. So all this vanadium can be taken back and used in other industries. So that is how simple it is. So apart from chemical, there are basically plastic tanks which you can simply use, reuse, recycle it and use in other applications. And the rest of the component are like battery stacks, like basically they are plastic and some carbon material. So the graphite carbon can be reused. They also do not degrade or do not take part in the reaction. So they can simply use in other industry as well. So there is basically all the 100% components can be recycled in vanadium battery. That's the beauty. And you don't have to worry about chemical segregation because it's just separately stored in the tank. You can just get it back from the out.
Oh, that's great to hear. I think thank you so much for all your answers. And before I let you go, I have one final question for you, for Nepal to be able to enjoy the benefits of these flow batteries. What changes in policy would you like to see, and what message would you like to give to these stakeholders?
Okay, first thing is that this battery are new to the authorities or even the country. So definitely having some incentive on the peak saving, also having the off-grid solution, that will definitely help, because your grid or infrastructure not that great so far. So if the off-grid solution can be done, if the EV charger can be just installed with the flow batteries and solar PV at different places, all the highways in Nepal, definitely it's a good move. So just batteries are probably slightly expensive right now, and if the government can incentivize, definitely there's a big scope. Definitely there is.
No, thank you so much for all your answers and for taking time out to speak to us, Arjun. Thank you so much for sharing your insights with us today.
Thank you. Pleasure talking to you.